Hey, it's Coffee Compiler Club. We're here to talk about compilers and freezing weather and language runtimes and I don't know what all, typing systems and garbage collection and why we love or hate Kotlin. That was an interesting thread to read. You're all being recorded, and if I get after it, YouTube has the video in a couple hours, so that's it.
So which thread? The one Jim and I were talking?
Yeah, you two are going to town on Kotlin's versus whatever choices that JVM made 20 years ago. And I was just like, yeah, okay, fine. It did, I guess I'm with you. They did what they did. It totally made sense in that era. And it's been 25 at least years.
Yeah, 27 now.
27, yeah. And maybe you would do
Yeah, I
things
mean,
different.
the shocking thing is how many things they got right.
Yes, yes, they got a lot of things right. Yes.
Yeah.
Would have been nice had there been a better version of closures at that time, but
I love Bjorn's. I don't like Bjorn, but I love his statement about languages, about being only two kinds of languages.
ah,
Have you heard this one?
I'm certain I have, but repeat it because it's been a while.
Yeah, there are two kinds of languages that people complain about and languages that no one uses.
Ah, there you go. Yes. Okay.
And guess which one he has?
Yes, exactly.
Yeah.
It definitely beats the alternative. It's fine.
I think he recently wrote a paper in response to American government organizations not recommending C++ anymore. And it feels like he just invented the third category, languages nobody wants to use anymore and people complain about. So,
There are a lot of people using C++ for a language no one wants to use anymore. That's
Yes,
fine.
but nowhere near as many people.
I was just going through the developer salary survey from Stack Overflow earlier, and it's surprising how low C++ falls on that list. It's strange to me.
It kind of makes sense though, because it's not adjusted regionally. So think about it this way, that a lot of the C++ stuff has been moved to lower cost areas in maintenance mode. So it makes sense. Like at Oracle, our accounting was, for example, I had a big team in India. So I could hire one person in the US or 5 people in India.
Right.
So,
which does not really work because the 5 people in India did not get more stuff done than the one. Anyway, different story.
We had a great team. We had a great team in India because we picked up the Sun engineering team in India, and they were actually engineers, and they were brilliant. Loved them.
I had several go-rounds with different companies, and the normal answer was if you had a team in India, it cost more American engineering time to fix their crap than it did to get anything out of it. It was a net negative. And the managers loved it until you could beat into their heads. It was a net negative.
Right. Well, you should never let CFOs build engineering teams.
Yes.
That's the lesson. Like,
Yes. But this was like in the 80s, 90s, 2000s even. If you were a certain style company, you started a certain way. Yeah, there was a bean counter who was building, he hired a CTO, chief VP engineering, but they didn't get to pull the strings on who to hire. They got told, hire an India team, they're so cheap. And then, it's a giant net negative.
And Cameron, I think you guys were just like super lucky. I mean, while I was at the gaming company, we had a studio in India, so that was basically internal, and it was still shit.
No, but that's what it was.
Yeah.
And the Russians, India, Russian team was decent.
Yeah. Oh, the St. Petersburg team was brilliant.
Yeah.
And they got shafted because of all the Putin moves, so Oracle had to let them go. But they're brilliant. But the thing is, if you're going to build a team anywhere, it doesn't matter if it's India or the US, you have to have an anchor manager and you have to have an anchor engineer. You have to have someone who's willing to invest the time to hire and attract good people, and you have to have someone who can mentor and train. And there's no free lunch. You gotta invest the time and effort.
Yeah. Somehow it doesn't seem to work to just have X number of bodies.
Yes.
And that's going to make you more efficient. doesn't really matter where you do that.
Yes.
You know,
That's been a slow lesson to
Y-
learn. In
y-
my experience, it's a slow lesson for management to learn.
Yeah, the lovely project management kind of rule, right? If you have 10 people and they need 10 days, if I put 20, I can get it done in 5, right? That's how it works.
Yeah, well,
Right,
it's all
exactly.
points, right? Story points. So yeah, actually,
I think
this is relates to a topic I was thinking of asking Cliff for a while. I was going through old videos a long time ago. I came across you talking about one time you spun up a team of 4 developers and you tackled some project that someone that you had come into had been. I don't remember if this was H2O, or if it was some
4 to
in the
5 would have been
fund.
fintech startup.
Yeah, okay. But it made me wonder, like, how do you manage projects like that? Like, how did you go about doing that? Because, you know, I'm assuming that it's not, it's and maybe this is not a great conversation for this channel,
Oh,
but
I think it is. Fine.
but you know, spinning up a high performance team and then getting them to actually work at high performance,
Right.
like it's not easy.
So I'm a well-known asshole in the industry. So if you're willing to work for me, you typically want to learn something. You want to have, or you're expecting to get pushed to do more shit or do better shit. And so a lot of the issues were basically finding people who would work with me at all. Promptly they're there to learn and to get something cool done. And so I didn't have to go through some amount of motivation that I inherited when I started with other teams that I came in as sideways instead of hiring. So in that sense, it was somewhat easier. I hired 1 or 2 friends that I knew well, that we had worked together before, and recommendations from them. And that got us up to actually 5. And, you know, and despite being sort of a technical asshole, I claim I'm nice in person and I never mean bad and I never mean to tear you apart, but I do mean to understand what you're doing and why you did it this way and why you didn't do it that way. And maybe there's a better way. And if your ego can handle that, you wouldn't be with me if you couldn't. So you could. So we get technical, get quick, get meritocracy quick or something. And suddenly, you know, the team gets functional. It's always safe to make a mistake with me. But you will hear about it, but that's it. It's not you. It's a mistake was made. How do we do better next time? And that's part of it's a safe team to work on. And that's part of let people run as fast as they can. And then if they make a mistake along the way, they did, and that's okay. And let's go pick it up and go again.
And how do you manage sort of planning and architecture and making sure that the pieces that people are building are actually going to come together?
Well, a team of that size, like at H2O, we pushed out closer to 20 and there was less fine-tuned control. A team of 5, I kind of architected it myself in my head, and I grabbed what I thought was the nastiest piece. And then I said, well, we need to go from here to there and from here to there and from here to there. And people milled about a little while and decided what pieces they wanted to grab. And, you know, went after it. And then because it's only a team of 5, we talked a lot and we sat in one big room and adjusted plans and as we went.
Yeah.
You have to tune between 2 things, right? Giving people the space to try things and potentially make mistakes, but also not giving them infinite rope and waiting until they're so far down the road that they have a vested interest in holding on to something that's crap. Yeah.
Something that's not working. Yes. So at H2O, I had several conversations where I had to say, you know, what you were working on was really cool and our business needs have changed and you didn't make a mistake and there was nothing wrong with what you're doing, but you need to stop it and do something else now. And that was a sort of a delicate dance. And then some of that really was business needs change. And some of it was, you know, there were more people. And so the time I came around to recognizing that you were chasing too far down a path, you know, it was a little longer between steps.
Yeah.
Somewhere in there, I hired a guy who was a great engineer to be a line manager, and that helped a lot. It kind of sucked that you burn a great engineer as a line manager.
So what
He
is the
thought-
line manager doing?
he would check in on everybody. So he ran the weekly stand up, and literally we stood up in a big circle, and that's so that you would demand the meeting was short. I pushed really hard on this, and I think it worked out well. People gave a summary that was literally under 30 seconds. 10 was preferable. And they had to end with, it's going well, I'm making progress, leave me alone. Or I'm having trouble with this issue and I need somebody to come talk, or I'm blocked on that. And then we would make sure that all the people blocked by X were talking with the people who were supposed to be doing X, and making sure there was a coordination there. And it really was, that was the correct situation, or the person who was the blockee was doing somebody else's work and had to get pivoted around or whatever. So there was sometimes a shuffle happened out of those meetings. So he ran that, and he did the finger pulse on every engineer kind of thing. Like I went around once a week and talked to people just briefly, hey, how's it going? But not in depth. And he spent a little more time with people. That was, I would like to say that was not a full-time job, but it was watching him. It was very clearly at least 50% of his time. He was thinking he was going to get more engineering done, and he was doing some engineering on interesting work we really wanted done. And I kind of knew in my heart of hearts that he was well under quarter speed with the management load on him, and he didn't realize it.
Sometimes that role is called a technical project manager.
Ah, okay, fine. So without any official training on what you call titles, that was sort of how that one panned out. Whereas that team of 5 guys, that was us in a room and me just, we were chatting all the time about what we were working on. We had a guy basically full-time QA, and guy basically full-time doing inhale of new data formats for every fucking exchange, and every fucking gateway to every exchange has a different log file format for no good reason. They're all required by law to be saved for like 7 years in case you're caught cheating and you have to get in front of a judge, but who the hell reads those logs? So we had to have a full-time guy doing logs. And I did the top level architecture and had a guy doing data science pieces. And there was another guy doing what the hell now? And we ended up with a bunch of visualization shit that I only did half of, and maybe that was the guy doing visualization. I'm trying to say the QA guy did some of the visualization work too. Anyhow, parts moved around between people, and people grabbed different things. And of course, the design is built as you go. So some things that you would like to have said were fundamental and unchanging, and that's what I'm going to build on, are actually changing quite rapidly. And so people, go back to what they would have considered their raw base input and had to change again how that happened. So some amount of churn because you're learning what the hell you're learning.
Yeah.
That was one where I came in sideways on a big team that was dysfunctional. And I tried for a while to make the dysfunctional team functional, but they were in Chicago and I was in California, and the distance was too great, both physically and conceptually, the way they thought about how these things were done. And we had a chief VP sales, whatever, chief sales guy, who in the end basically was a cheating bastard and embezzled butt tons of money, and was on purpose trying to keep the engineering team dysfunctional so that he could wrest control away of the direction of the engineering from me without telling me or the CEO. So that whole setup was dysfunctional as fuck. And now I recognize the red flags. At the time, I didn't recognize the red flags. So I eventually started pairing off people from the dysfunctional team from the worst upwards. And then it hit a tipping point, and the team basically collapsed. And I looked at what was going on, and then we had to blow up with the sales guy, and we understood what was going on. I said, okay, reboot time. And I guess it went in the other order. It was dysfunctional to the point where I said, no, I'm just going to cut and run. I'm going to keep who will work with me and flush people who won't, and pick up a team in Silicon Valley, and we're going to redo the project from scratch. And the redo totally worked. But as part of the cutting the engineering in Chicago, it cut our burn rate by a huge amount because we dropped the team size by a factor of 4. You double salaries in California and drop the team size by a factor of 4. You didn't actually double the salaries. You 50% of the salaries, you cut the team by a factor of 4. And then the sales guy blew up, and then we discovered he had been telling lies, blatant lies between different groups of people to keep them from talking to each other.
So what are some of the red flags you learned to notice?
Well, the CEO was very inexperienced, and I wasn't present next to him on a regular basis. So he gave an unregulated company card to this sales guy. And the red flags were two. One was the sales guy asked for an unmetered card, and that's a red flag on a sales guy. They should expect to have their card looked over by a CFO on a regular basis. Or the other way is you build on your private card and then you hand back to the company a payback, and that demands that you keep the float in your own pocket, which means that you pay attention to the float. He wasn't. The other one, of course, the CEO handed him that card.
Reimbursement.
Yeah, reimbursement, right. The CTO handed him that card, and the CFO was not a CFO. She was just like an accountant. We didn't have a CFO. We have an accountant lady who was somebody's friend of a friend doing accounting on the side. She never raised a word because she wasn't her job to do so.
Right.
The sales guy had outrageous
numbers, not thinking about
thought this was wanted or desired, and just let him slide.
Yeah.
So red flag 1.
But it must take a while to realize that that's not something you're going to find out about on the day you start.
No. Yes, it should have been. So see, he didn't start, or he started just roughly about the same time I did. I didn't push hard enough to get the books. I demanded right to see the books, and I never demanded to see the books. Had I seen the books, I would have walked down, what the fuck are these expenses? And then gone to the CEO and say, your sales guy's buying top tier baseball stadium boxes to, seasonal boxes to host people in. Is this where we want to spend our money? And he would have said, like, what the fuck? No. And then, okay, why wasn't this caught by the CFO? Well, because, he doesn't have a, reimbursement situation. And then, okay, I could have caught this, and the correct answer for me was to, yes, get the books on a young CEO and do what a CFO would do until I believe that the CEO is not screwing up. He was a flashy playboy guy. I knew that going in. The CEO.
This was a decent sized company when you went in, right? But I guess you were coming in as a sort of an executive level.
I came in as CTO because they had a technology problem. He had the guy who had been a high frequency trader algorithm writer. So he was a high tech guy, but he was also pretty much, basically a playboy, mid 30s and girlfriends and fancy cars, right? So that's fine in that sense. I wasn't worried with that piece per se, but it did mean that he was more excited about playing games than about running a company per se. He had a cool idea. There was a market for it. He was having trouble getting an engineering team to do it, because the difference between one guy writing one thing for one situation and you're trying to make a product that has broad market appeal and therefore it is robust and reliable in all situations and has the right answers. And in particular, the results had to go in front of a federal judge from time to time, and therefore there had to be strong provenance of where it came from and why it came from, and how you dealt. So there's a bunch of rules that were government related that he didn't want to deal with, and wasn't really prepared to deal with. So those were all things that I took on myself to make sure they worked. That was part of why I got hired in. Get the technology work at all. He had a toy that he had written that clearly wouldn't work in any other situation. He had a team of 20 guys who had grand plans, who had built a bunch of parts. The parts never worked together. I saw immediately the technology fail on the team. They had, dysfunctional teams. What it red flag for me, that you asked for what are red flags, another red flag for me was a bunch of guys in an office, 20 guys in an office grouped together in groups of, 3 to 5 or 3 to 6 or something, siloed. They weren't talking, and they were clearly not talking. And that was pretty soon figured out. That's a red flag. Why are you guys not talking? Okay, what's
Like
the
these
plan?
groups of 5 weren't talking to each other?
Yes. Right. So everyone knew that there was a plan. No one knew what the plan was. Right. There is an integration plan,
There
but
is
no
still
one
a
could
plan.
tell me what the integration plan was. And has any of these parts been integrated together at any point in the past? No. Has anyone started on? No. Has anyone had tried, even looked at the API? No. There's nothing. Right. But we all know that there's a plan. They just don't know what it is. Well, that was the sales guy keeping the teams from talking to each other so that he could manage the control of the company, basically. That was his theory on how he was going to do that. And I threw I messed up his plan by coming through and figuring out that, in fact, shit was shit and people weren't talking. Now, it didn't go from there to, this is a red flag, I need to sort it higher priority. I was first trying to figure out what technology they had, and could I come up with a plan? Instead, I should have said, why are you guys not talking about the plan? You have your parts, they have to fit together or it doesn't work. Who are you talking to on your counterpart teams to see that they fit together? Why have you not even explored this API? So it's not that they didn't and needed to, it was, why didn't you explore already? That's the red flag.
Yeah. Although sometimes I find the funny thing is, if you do things, if you came in and fixed their communication issues, you might have ended up in a worse local optima where you were then in a place where this crap that they had built was semi-passable.
Yes,
and you
exactly.
couldn't quite put together the impetus to do the rewrite.
So between that, I was looking at what they built and seeing if it could be put together. I was also looking at how I would do it. And how I would do it would be to drop 9% of what they were doing. In particular, throw the database out in the middle. Somebody had to have a database because there was data involved. And no, you didn't. You throw that out and fucking get away. And the data set sizes were small enough to work well with H2O. So they were in the high gig, low terabyte range, which H2O would totally eat up.
Yeah.
They had a bunch of other stuff that I never really understood why they had gone down that path. So there were some definitely things that they had grand plans for how they're going to take over the world, and the grand plans included super futuristic. This is how we're going to make everyone rewrite their data formats and their log files, and this is how we whatever. But stuff that maybe would pass in 20 years if you became a dominant monster in the industry and you could demand such changes, but weren't going to happen up front or anything. So, here's how we describe every possible log file format on the planet got turned into, here's a log file that we can eat one of. Here's a second log file. We're going to comment up all the different things that were necessary to eat the two that were common between them and leave uncommon the uncommon. Okay, by the time I got to 4 of them, I had a pattern of what was actually common in the industry and what was going to be different for every log file. And then we just reformatted the log inhaler 4 or 5 times, and it got cleaner and cleaner every time. And then, the last go round, there was a chunky thing that would eat a log file and a dozen abstract functions you filled in for shit that, would let you report things. And they were all small things like, here's your desired time zone. What time zone is this guy in? And what time zone is he trading with by default? And what is this? And then some of the remapping functions for how they discovered or traded, how they just called products. So a product like corn futures on one market would be under a different name as on another market. Those, since they're traded across markets, have public well-known files. So you have this translation file. So you filled in the translation file as one of your abstract porting jobs. This is this version of translation. And everyone had 3 or 4 translation files of various kinds in different situations. This is how we compress time date stamps, and everyone had a slightly different way to do it. So you had to have a function for that. Whatever, fine. There were a bunch of them, but not too bad. Each of them were pretty minimal now. And the log file guy was pretty intelligent about applying as needed and would eat the log files straight up on the 4th go round. By that time, toward the end of that whole project, I did have a decent young engineer in Chicago who never got attached and screwed up with these other old school trader dudes. Totally a team player, great guy. He was churning out a new log file format once a week, which was as fast as we could inhale customers. So that was totally fine.
It's so funny. There's just like got me thinking about log files I've had to deal with in the past. And I think the funniest one I ever came across was in Epsodic formatted log file, which was a sequence of about 500,000 or 1 million full screenshots of the green screen.
Yes.
So you had to just pull the data out of the sequential form fields.
Yeah. Fucking sequential form fields. I dealt with those.
Yeah. It's not that hard once you figure out a plan, but
right. But not
when I came onto the project, the plan of record was to hire several hundred people to data enter it manually.
Oh, geez.
I think I got it done in a week.
But say, yes, exactly. There's some time to parse, and then it's all done in an instant. Fine.
I had never heard of Epsodic before that project.
No, I went to Texas A&M as a computer scientist and on their first entry program. So we all got to program on the IBM 360 mainframe, which meant Epsodic.
Yeah.
So, that was just my starter. That was also where I learned how to break IBM operator controller JCL. And and then crash the mainframe. Security by obscurity was all good up to a point, and then I came along. It didn't work anymore.
Yeah. All right.
That was an interesting learning experience for me in that company and as a whole, both about how fintech, how the capital markets work. It's kind of shocking that it works at all. And it's just a giant pile of everyone trying to cheat each other so badly that they mostly keep each other honest because they don't want the other guy to out-cheat them. It's kind of, it's kind of spooky that way, and kind of, okay, maybe this kind of works, who will watch the watchers themselves? Well, everyone's got knives and they're all pointing at each other's throats while they're trying to make money off each other by selling each other shit. So, okay, kind of, sort of works.
Yeah.
And when we looked for fraud, we found it by the butt ton. Just an unbelievable amount of it. It's so fast, so easy. Like the tools that had been in place before were so pathetic. And just the simplest machine learning model on big data sets would just pile it out instantly. That was our major sales. It would be planned. We would go in, we would say, okay, we have to have a JVM inside your data center, inside your firewall. You have to feed us a data set. The easiest one is the one you just did today. We'll inhale it. And in 10 minutes from when we stick that damn stick on your machine, you'll have it up in a browser to look at our analysis of your log file. And the fraud things will be popped to the top. And then the CRO, the chief risk officer, compliance officer, will be looking at their fraud things. And they had in the past, literally people were doing green screen cut and paste into Excel spreadsheets as part of their workflow. They would be looking at a browser dump of their big data with, this is your top fraud guy, and here's one, here's another, here's some of the frauds he's doing every day, here's today's, and break it all down and hand it to them like you'd try to explain it to a judge. And we'd have guys screaming out the door to the CEO, we got to talk about Jim, we got to talk about Jim, and whatever. They would just, that was the sales call, was the panic run when we showed them their fraud to their face. Just unreal.
Yeah, it seems like it seems like an offer they can't refuse.
We never, ever would claim that we would tell anybody about what we saw. That was all part of the normal thing, but it was pretty clear. If you knew and you didn't act, if you didn't know, you were not in trouble. And if you were doing reasonable efforts to know, you were not in trouble. If you knew and you did not act, now you're also complacent. Right.
Yeah.
So as soon as they saw it, they had to act, and they did. And that was, like I said, that was our sales job. Fine.
Good. I mean, hey, it's great to have that compelling sales hook.
Sucked so bad when it didn't go. The tech worked, the market was there, customers were eager to pay. CEO just wasn't doing what he needed to do. It was his giant story to lose, and he did.
Yeah.
whatever, how you want to say it. It was his to lose, and he did.
I mean, that's a very common story. That seems even you got a good startup going, there's still the odds are against you for those reasons, for sure. That's what I've seen in my experience.
Yep. There you go. I lived it. Fine.
So,
And you know, much as I love to hate on Oracle, you know, Larry Ellison's a jerk, but he made it work, you know, and there's something to be said for that. Fine. And maybe he mellowed out in his old age. I don't know. Maybe not.
yeah.
All right, what
Okay,
else?
some programming stuff.
Moving off of engineering team politics, what? Failed startups, what?
Well, we'll continue next time with the failed politics.
Yeah.
What else? Yes.
Well, actually, I have something else if you guys want, but if someone else has something, please dive in.
Go ahead. Go ahead.
Okay, well, I was thinking about so basically, I've got in the sea of nodes the call sites like I think I've shown you before, and I can bring up some pictures if you want, but basically, you know, after my call sites are torn down, they're pretty straightforward. Arguments come into the call node, and then there's the return node, and then all the return projections come out of that. Right. And that is tied to the regions that the call happens in. My thinking was that after I do all the ideal stuff and eventually do inlining and stuff like that, it might be beneficial to go to a different form for the call nodes where they're no longer tied to regions. So because there seems to be nothing fundamental about them being tied to regions after you're done inlining. What's that?
Go from having a control flow graph to a program dependence format or program dependence web.
No, because all the functions would be separate subgraphs, not connected to each other. I'm just saying that
this is within one function.
Within one function. Yeah. So within one function without them being interconnected anymore.
You will change from a control flow graph to a program dependence web in one function.
Okay.
And your linearization, your serialization algorithm becomes a lot more complicated. There is one.
Why?
It's not trivial.
But where does that complexity come from?
Because, and I have to understand, we have to be on the same page in what you're trying to do with calls, but what I heard was, I have an operator, let's call it a call, but it could be a fucking primitive op that wants to execute independent of the surrounding context, where the inputs to it are no longer include a control edge, which is fine, but it also has a control-like effect. So I have a node that I'm going to expand later into some fancy control flow. It's a call, you're going to inline it or not, or whatever.
No, so this is after all the inlining would be done. So I'm saying this is just the step before scheduling. So okay, everything that I'm going to do is done, except register allocation and scheduling.
So you still have to have the calls dependent on memory then?
Yeah, so I have memory nodes tied into the function calls if the function, because I've done the optimization through the functions and then torn the call sites down back to their original form, functions have only the memory edges that they actually affect.
Let me tell you what happens with a program dependence web, and maybe you're not going to hit it because you're pinned by memory. So if you have a loop and has an if test in the middle that's invariant, you would love to unswitch. Since the loop test is itself invariant, it can be computed ahead of the loop, and you branch in the loop with an if.
Yeah.
If the if loses its control edge but is gating his outputs, or picks up a control edge that's ahead of the loop because it's always going to be run every time. So it's equivalent to being pre the loop, predominating the loop. You get this funny form where there's a test you're making with control flipping outside of the loop being used inside of the loop to gate one of two paths. And that happens because you have a post-dominating control that you've lifted on the if, because it's always going to run 100% every time. Why not allow it to hoist? So if you take the control off a call, or move it to a higher place, it's allowed to execute more often. But if it's gating other control that comes later, you now have this funny shape that doesn't have a control flow graph directly. When you deserialize or serialize that back into a control flow graph, you have to make a call that you're going to take an if test that's a loop invariant and push it into the loop, not out of it, or clone the loop body and loop and switch. And in the general case, you can get really twisted things there where it's no longer obvious how you put things back into serial forms. You have to switch algorithms to a more complicated serialization algorithm. And then you have tough choices like taking some loop invariant code and pushing it into a loop. So that's the sort of the general issue with moving away from a true control flow graph. It's a slippery slope. You can rapidly get to a point where you need a new straightening algorithm. So whatever transformations you do on your call nodes, you want to make sure that you can still pick out a control flow graph. Now having said all that, if you have a call who's pinned down below some control point and you remove it, the call now floats, and you get a different problem, which is the call is only going to run on one path, one part of a diamond. You allow it to float ahead of the diamond. You now execute it more often. And so there's a cost there, even if the memory allows it. Like for whatever reason, I have a call that I know has no memory side effects, but it has a non-zero cost, or it'll fucking inlined it. So now I've hoisted it, it's running more often.
But if I wouldn't remove all of the pins, like, you know, just the ones for the function, like just the ones for the function directly.
For the call directly.
Yeah, the call directly. Sorry, that's what I meant to say.
Yeah, I'm saying,
so
when you start to let those things move, decide that you want to treat it like it's an atomic op that's free to move about, like an integer add, integer multiplier, atomic ops.
Yeah.
And it happens to be a call because you're going to expand it like you're doing an atomic compare and swap operator or some funny primitive like that, a non-obvious primitive. Well, you still want to treat it like a single instruction, but it's going to expand internally to a bunch, or I have a call for whatever reason, but I don't mind hoisting it to places where it's just going to run speculatively, even if I don't need the answer. Like, I don't care if I fucking hoist it.
The general promise of the scheduling is that although occasionally something is executed more often, you're generally lowering your cost, right? I mean, that's the sort of reason that
the standard code motion algorithm I use pushes things aggressively into lower frequency execution regions.
Yeah.
But in the cases where you lose pinning, you can then pick up multiple uses that force you high. Like if I have a three-way split and a thing is used on two of the three, and I have two copies of it, and I let them remove their control and float, and then now they become common, I have only one copy. Now it's used on the third path as well as the other two. Okay, well, that's all good if it's an add, and that all sucks if I'm doing, you know, a lock or something stupid, something expensive.
Yeah, but on the other hand, you could have a function call that's in a loop on one of those three paths that's you know, hot, and you might move it to a colder place. Well, so yeah, it could go either way, right?
No, the commenting forces you, gives you fewer choices on where you schedule. Removing the control edge allows commenting, which removes selection on where you're going to put the thing.
Do you ever go away from commenting and say, in some cases, you want to split things that should be common? So basically,
yes, I do. I aggressively comment in the core optimizer, and when it comes time to do instruction selection on an x86, I will eat up addressing modes aggressively or greedily, or whatever, however you want to call it.
Yeah.
And there's some attention paid to removing an intermediate result because every use of it is greedily eaten by a different addressing mode. So effectively it's cloned, but that's only cloning like shifts and adds.
Yeah.
Other things I'll clone if they're not a call. Calls I won't common, but other things common, and therefore they occasionally get lifted. Calls I'm leery about that one on.
Yeah. And so I was thinking about this, and then I was also thinking that the obvious next thing to do would be to actually explode the call into the actual steps that you take to make the call in the graph, and also like idealize that.
So I only make a call with a call op. So one machine op.
So right. Yeah, because that's the JVM.
No, it's because it's an x86.
Oh, but what about like placing the you have to put the args into the
those are
specific registers.
Those are exploded out, and those are proxy, or those are responsibility of the register allocator. The register, when I do in the ideal graph, I just magically assume that all arguments land in the calls registers as needed. There's no separate I'm moving arguments about in the ideal graph.
Right. So you wouldn't say this goes into register 1, this goes into register 2, this goes into register 3.
Not till a register allocator comes along, and he does that job. And he occasionally has to insert copies to make things move. You know, if I return in one register and have to pass out in another, you're hard guaranteed to have a copy in there.
Yeah. So I have some stuff like, for instance, I have to load up the call address.
Okay.
And I have to do the
so
stack pointer manipulation manually because I don't have like a call instruction. So
you would jump and link or something.
Yeah. So I have to sort of deal with moving the stack pointer, and then I do a swap.
Right. So when I go from ideal instructions to machine instructions, some of them expand into more than one machine instruction. And then those instructions schedule. Then I schedule. There is a flip to machine code, schedule what you got.
Yeah. Yeah. So my first sort of thinking through this, and I was just drawing it out, was I started drawing like register nodes all over the place, and is like, I don't know, this seems a bit wrong. So I think maybe the thing to do is to have a, the swap instruction depend on the actual argument, and then the register allocator
I don't have a swap instruction.
Well, so the swap instruction is kind of the closest thing I have to the call, because I use that. So I basically put the instruction address into a register, do swap, and then I get the return address.
Yeah. All right. So jump and link variant of jump and link. Yeah, fine. I see. Yeah, that one's that's your call. And you put the address in a register as say an immediate value, and that's so you would expand a call into two instructions: load immediate, jump and link, or swap, or however you want to call it. And so you get two instructions, and they should schedule. Go to machine code, schedule it. Register allocator would guarantee that the load immediate hit the register needed for your swap.
Yeah.
That's an interesting call instruction, because you could swap with anything then, right? Any register.
Yeah.
Return address shows up in any register. That's an interesting architectural design.
Yeah, well, it's interesting, but I haven't found any use for it. Well, it is useful for loops as well.
No, micro calls where you're just going to go in and out. Every time you add some flexibility here, then you can arrange that no one has to spill or prologue, epilogue spill code for small enough functions. There are plenty of functions in Java where someone asks a question, they fail, they get out quick, and they don't do anything. And I actually spent a fair amount of effort in the allocator to try and recognize these situations and not have spill code show up before the start of everybody. Like, there's no prologue spill per se in the C2 register allocator. There's just hot and cold places spilling. So if your hot path is come in, test for null, get out, else do crap tons of shit, need lots of live registers, then the spilling will be no spilling when you come in, test RAX, jump equal to return, you're done. Now, oh, you spill like a mad dog because I have to have all these registers, and the spill comes after the test and exit. So there's no prologue, epilogue forced on you per se, and that's actually helpful. So in your case, it would be same exact, even better. If I happen to have picked for my call swap argument a different register for everybody as they're coming and going, the odds of collision would get lower and lower. And now I can say, swap in, test for null. Oh, it's null. Swap out. Jump to the return in the register, and you're done. And no one had to spill any registers, do any pushing and popping, nothing. It's like even fewer instructions. So I'm thinking that's a cool architectural hack that I would totally, it's cherry picking, but you're at the leaves of you're cherry picking at the leaves of the call graph execution path over time. And many of those paths are just up and down constantly. And if it's small up and downs and there's lots and lots and lots of them, you can win by such stupid things.
Yeah.
Such hacks win.
I'll have to, yeah. I guess it really comes down to, well, I have to think it through. Yeah. So yeah.
Don't worry about it. I mean, you get that far, you're optimizing the next layer down. Like get some code gen going first.
Yeah, that's where I'm at. So so basically I took your advice when we talked about the other day about a bunch of tests. I wrote, 100 or so small tests, and I've got them all passing now. I actually had a surprising number of stupid cases that were broken. And
exactly my experience, yes.
And I'm sure there's more, but all of those are passing, and all of my old tests, the big tests, are also now passing and producing code that looks good. So I'm now finally ready to start doing the actual code gen, which I've been thinking that I was ready to start for the last like 3 weeks and not been quite ready. So
sounds good.
So I'm very happy about that. I'm very frustrated because I didn't expect this stuff to take as long as it did.
What do you say? When I switched to more aggressive testing, I found lots of stupid shit, and then things started working.
Yeah.
And it took longer than you ever thought. And that's where I'm at right now. It's my AA update. I'm middle of going from the main code base only doing forward flows to doing blended forward flow and Henry Milner style. And lots of stupid things are failing and lots of them are working, but only tiny things, but they're starting to work. And then my hope is they'll ramp up rapidly after they start to work more.
But isn't that like the general rule? You get 90% done in 10% of the time, and the remaining 10% take 90% of the time?
Yeah.
That's nothing. The problem is that the remaining 10% of that remaining 10% takes 90% of that time. That's where the real time goes.
Yeah, that's kind of where I started from. I thought I was going to be done with this 2 years ago, and then I was like, oh, I'm cutting new ground. I guess I'm doing research instead of running a compiler. Ouch.
It's a research compiler.
Yes, very much so.
It's the new Haskell.
Let me see here if I have. That's probably nothing worth looking at though. Oh, I figured out like some of these typing games that if you guys are reading the chat we went through, what is the type of X plus Y? It was kind of scary. That one I probably have a correct answer for. I don't have, I can throw an example that's not worth looking at. Basically it says you have to have an operator plus that takes, self on the left and produces something on the right, and that's the result of the function. And I don't know which operator you're going to call because I don't have any types yet, because you just wrote a function and bare space and threw it out at me. And it was not exactly the type you're thinking of, the function, infer the function, the types of function X plus Y.
Yeah, but
there's no type on X or Y, so what the hell are you going to infer?
But you will delay more, so to observe the usage of the.
Here's the code block.
Yeah.
I should share a screen maybe if we're doing the code.
Maybe
Google
share screen.
Docs. Yeah, it's just a one-liner Google Docs. All it
Mhm.
says is, what is the type of that? Well, the answer is, you got no X, you got no Y, you got no types on anything, so ain't no type.
The type is
Since I can
structural, maybe.
overload the operator, X could be matrix plus matrix for all you know. And there's no
So
reason you couldn't be stupid and hurt yourself and do 1 plus string is, concatenate a 1 onto the string. And yeah, I would allow you to do that, but I'm not going to write it. You're allowed to shoot yourself in the foot if you want.
So we're back to JavaScript.
We're back to what?
JavaScript.
Yes. Yes. No, it's strongly typed. So I'll right now I'm going to tell you, I don't know what the type of the operator plus is. So I don't know what the type of things are is. I know and the reason I'm complaining is because I'm expecting to do overload resolution on the plus operator. I don't have enough facts to do that, so I'm going to complain. My other option is to allow you to write code which the overloads have not yet resolved. So the program is in a pendingly not yet strongly typed state. And that would be exactly what you'd expect if you were to write a module and you're going to link it against something else down the road. So I have to allow that. And right now my error reporting is too aggressive and I'm going to complain at you and say, I couldn't resolve operator plus. And instead I want to say something along the lines of, this has got an unresolved operator plus in it, but that's okay because you're going to resolve it before you run any code. I see Cameron grinning like he has some evil thought in mind.
So something that I've been struggling with myself related to this, like you've got this function xy and you just return x plus y. So if you've got two calls of this function and one is doing ints and the other one's doing matrices,
yeah,
how do you type this function? Like, can you end up with really two? Like the sensible thing is that to think of it as two separate functions.
Okay, so let's do that.
What does that
So
mean?
let me call this add, and then I'm going to say, give me back a pair of results. What do I call add
You have
with
three
1 and 2?
functions.
I'm sorry. Share the
You have
doc.
three
Let me share the doc.
functions. You have the generic ones, and you specialize up to 2. That's 3.
Yeah,
Uh-huh.
yeah. I can.
And then as you specialize, you replace the code in the generic one to redirect to the specialized ones based on type.
So how do you choose which one you're typing against?
Well, are you JITting, adaptive compiling ahead of time? What's the?
I'm going to type this, and then the jitter is responsible, or the code generator is responsible for producing the specialized versions. The integer add, I'll guarantee you, will specialize. The string one will not. It will go some generic route and have some more overhead on the call.
So
now
I guess you're always starting at the generic one, and then you might specialize to the same thing that you've already got one.
I'm going to solve the problem of specializing without getting code bloat out the wazoo at a later time. I know how to do that. I'm not going to. I can theorize what my strategy will be, but it will be something pretty generic here, where I just say, you've got a bunch of primitive args. I'm going to specialize, and there are not too many of them, so I'm not going to have too many copies of things.
Right. And your types can be constants as well. So you could have like a specialized version with 1 and 2, and another specialized version where it's like some int range and some other int range. And once your int ranges.
Yeah, the situation there's likely to be that I'll specialize for very common constants and null, and not for any other constants. So if you happen to use 1 all over the map, or the 1 is used a lot, I might specialize you, or happen to know that you're calling with an argument 1 for whatever reason. But that's a totally an optimization game here. So now let me go and throw some types in here. So add is I don't have a good syntax here.
When you say you specialize for constant 1, would that mean you're basically removing 1 parameter?
Yeah, remove a parameter.
All right.
Call. Yeah. Let's just see. Let's call this. I'm picking type names as uppercase, but the type here gets ugly in a hurry here. So the type for this add calls, its first argument has is a class thing, like integers have an integer class and strings have a string class and so on. That class has an operator plus. The operator plus is always an overload. The overload has a minimum of a function which takes the same class and some y type and produces a z type. And then back to the add, the second argument is the y type produces a z type. So this is the type I'm getting. And I haven't resolved the operator plus's choice because the ... on the choice says there are more choices and I don't know what they are because I don't have an X in hand, so I can't resolve it. So right now I'm complaining I can't resolve operator plus.
Does the operator plus should have always a concrete members like an int and float and something?
Well,
And
I haven't been told what the type of X is. I have no constraints on X other than it has an operator plus.
but
If I
Yeah,
call add 1, 2, that call site X is known to be an int. For
Yeah.
that one call site, I will tell you that you need operator int, the operator int add, which in fact does int plus int to int, and he will give you a type for that add as it's returning an int.
but
So the
you will
type-
have an overload that has an int as a resolution for the plus operator.
I'm sorry, say again?
You will have the plus and overload that specifically concrete to ints in order
Yes.
to resolve.
So
And you
it's Hindley
have-
Milner. So while I know the type of add has an operator plus, and I don't have it resolved in all contexts, for an add of 1, 2, I totally know that it's the int to int add producing int.
So
I can
In-
type this one.
because
the string plus
the
string.
ints have an operator plus.
Int is a classed object.
Mhm.
It has a class, a class of integers.
Mhm.
The int class has an operator plus,
Mhm.
and operators minus, multiply, divide, abstract, blah, blah,
So
blah.
each class has to define its own plus in order to be resolved.
Yes. Every so I have an operational semantics now. I have an execution engine. The
Mhm.
execution engine says in the X plus Y situation, I have an operator of a binary operator in the middle. I'm going to look it up on the type of the left-hand side. So I look at X's type and I look up that plus.
Mhm.
Okay, so the way that lookup happens is because it's an operator, you have to have a class there, class thing. I'm going to go to its class and look an operator plus up. So for this type, X had better be a type of a thing that has a class. That class has an operator plus. I can infer that.
It's not
Or
like in the
type
Haskell.
left-hand argument is always the same as the self type, the X type.
It's
It's
inverse.
actually, I wrote class here. It's actually probably supposed to be X. And then the right-hand side has to match Y. You know, that's just standard type matching for Hindley Milner, and you get a Z out. Fine.
Mhm. Yeah.
So again, add of this also works fine. And the int add case, I'll flag it as it's got a primitive, so I'll push uphill till I get specialization, and guarantee that inlines to an integer add that's been inlined. Whereas the string one, I won't do that. And so you may get a generic call where I basically do a vtable lookup on the string. I'll go to the strings class. It's a vtable. Do a vtable lookup for plus, find the plus operator for the string, make a call, just this vcall, straight up vcall. And I'll pass you a string on your this and a def string on your that. And, he'll do whatever he does, which surely will be string concatenation, but, whatever you're going to get there.
Yeah, but be it the types here have not a plus operator, then it's an error.
And it's
to
an
the
error.
user.
Yeah. If you give me a left-hand side that doesn't have a plus operator, you'll get a type error. It says,
So this
hey, I don't
result-
got no plus operator.
Resolve to something that has to have the plus operator.
Yes, that's what I was trying to say there. That third line down, add, the type of add here is the first argument has to have a plus operator. That's pretty much all it says.
So
It's
is-
complicated because operators have an extra layer of indirection involved in them.
Yeah, in the Haskell example, this is sidestep requiring the num trait.
Yeah.
You know, it's the inverse thing. In order to the plus comes with its own implementations. This is a reverse.
You go to operator num, which then demands X and Y both have num, and then somebody has to still resolve if it's an integer num or a float num and pick which one. So I don't know where that piece happens in Haskell, but I know it happens.
So what?
Can you repeat?
Where in this process are you doing this resolution? Is this while you're doing the ideal graph, or is it a separate pass, or?
Well, it's while I'm in ideal graph. So I parse after I'm done doing bottom up things with the parser, bottom up typing with the parser, I get as far as I can get and simplify a little bit. Then it's called combo, and the branch I'm on right now is TV3 something. Yeah, it's called combo. It does forward flow, backwards flow, and Hindley-Milner in an integrated fashion. And combo's main loop says, while worklist not empty, grab a node off, do node.forward, node.combo backwards, node.combo unify, assert that shit's not broken, go again. Okay,
so it's basically the same type of worklist that the ideal graph uses.
It is exactly the same. If I comment out the unify, it's exactly the same thing. Yes.
Yeah, you know what? I actually in mine created a general mechanism. So I have.
Let me make sure we're clear here. There's an optimistic and a pessimistic variant, and they do different things. So I'm doing the pessimistic variant in the parser and post parse till that's settled. Yeah. And I do an optimistic variant.
Yeah.
Okay, and that's where the actual
and you only do the optimistic once the pessimistic is completely done, right?
Yes.
And the whole program is parsed.
Yes.
Yeah. So I'm only doing the pessimistic right now. But just in terms of like running that ideal loop, I created a nice little thing where I have the worklist mechanism and then a list of passes, and it's just basically a list of functions. And I have the thing manages one worklist for each item in the list of functions. So then I can kind of plug passes into the thing. So I started out with reduce, mono, and grow, which I adopted from you mentioned, and it works awesome. But then since then, I've added more. So I think I've got 6 different phases that it goes through. So I split reduce up into simple reduce, like simplify, which is the really trivial ones, like getting rid of fees and some constant propagation and stuff like that. Or like doing constant math.
6 layers in my version.
And so but because it's sort of general mechanism that just creates as many work lists and manages them as I have functions, and then I just throw in a list of functions. Like the other day I was like, I think I want to add that, split up the reduce into simplify and reduce, and that took like 5 minutes. And it was a really nice, so then I was able to simplify some of my reduce rules because there were less variation on types of things that could be coming in. Like I could never have an unresolved fee coming into a reduce or some, like into one of the reduce rules, because that is in an earlier phase. So that was, I was pretty happy with that. And, just put it out there.
So this is the top down work list. I took a little bit of debugging stuff out to make it a little clearer, but basically it's just the while loop and pull something and run the things.
Yeah.
Count so I can stop at a particular iteration within the debugger.
Yeah. So it sounds to me like maybe that kind of specialization stuff becomes another phase that I could add sort of late in the, like a later phase, maybe even above grow, where I say, look at functions and see if I can do any specialization. Or
let me pull up. I think we're talking the same thing though. This one's loop's a little uglier. I guess it's not really more uglier, a little bit uglier. So here's the bottom up one, the pessimistic one. And it has this horrible chunk in the middle here. How do I write this in C coloring? Java coloring. Anyhow, the thing in the middle says, if work lists one after another, and then do your shit, and then, you know, bump your progress and your counts
Yeah.
and loop again. And that's my 6 phases. 6 things I have now in the order they do them. Dead
Okay.
things die, then flow, which doesn't kill anything, it just does type flowing. Then reduce is monotonically reduce the graph size, that like strictly reduce the graph size. And mono says things that just canonicalize, but they don't grow or shrink the graph. And then rare things that might grow with the hopes of future reductions. And then inlining, which definitely grows, but has hard limits on how often it'll inline.
Yeah. I have I haven't implemented inline, but I have exactly the same list, except for I split reduce into simplify and reduce.
Yeah. Okay. Fine. Yeah.
And yeah, I guess the difference is that in my thing in my work list, I just have a list of functions and I loop through the functions rather than having a condition for each one. And then that thing actually manages the work lists as well.
I went
Very
through
similar though.
a couple of varieties of like priority sorted one work list, and that was just stupidly expensive for no good reason. And a one where I had separate while loops for each work list, and it was just too much stuff or whatever. So I ended up with this, but I wouldn't
Nice and clean.
Wouldn't claim it's the best layout I could get out of here either.
Well,
I
it's
think I had
certainly
one
clean.
where I
It's
had a
easier to
for
read
loop
than
over
mine.
my work lists, and each work list knows how to do a do for that work list, a do it on that work list.
Yeah.
And that was harder to debug because I had to pick a work list, and then the work list did a do it, but I didn't know which work list I was going to pick. Here, at least in the debugger, when it pops up, it shows me all the work lists, and I can just see the empty ones I'm going to skip anyhow and go straight to, oh, it's a flow or reduce. It's 90% one of flow or reduced that my current bug's in.
Yeah. And anyway, as soon as you do something, everything goes into all the work lists, and then you have to look at the first.
Well, I do a little care when I put things in. Flow and reduce get a lot of action, but mono and grow typically get thrown in once the start, and nothing throws in again except under rare circumstances. And then I took some of Bobby Eckhart's suggestions and had a lot of my throw you in a work list things are done now by the code that attempted a peephole and failed. At the point where he failed a peephole, he took the guy he failed on and made him put the this node I was looking at on the guy I failed on. So if the guy I failed on ever changes, this gets put on a work list to come around and recheck the pattern again. It was a one step backwards or off or something kind of thinking about it. And that actually cut a lot of extra code out about who got put on a work list for what. So I'm a lot tighter on, if you went on the work list, there was a reason that was sensible. I just didn't throw you on because blindly.
Oh, interesting. Because I originally thought, I think that's how you originally did it, because that's kind of how it was written up at the beginning.
Yeah. But right. So buried on here, like do flow or do reduce, at the end of them, they say, if I make progress, throw all my forwards flow or backwards flow neighbors on the work list. That generally works fine for flow, with a few rare cases. And the rare cases are handled not in the do flow, who just puts neighbors, literally neighbors, but they're handled by this independent dependence mechanism that I got a Bobby's suggestion, where if somebody's value type depends on something that's not a neighbor, then he throws a hook onto them. And so when I'm done with the do flow, I also say, and because you changed, grab your dependents and throw them on the work list. And they only go on flow and reduce. And if I have to get somebody onto mono or grow, I'm going to do something different anyhow, because those are too rare. So my normal story is dead. I want to happen first. I don't want to deal with dead and all these other patterns, but then flow and reduce do the 90% lifting until they stabilize. And then you get the monos and the grows to do some nitpicky shit. and then inlining kicks in if it's going to inline.
But when you do mono, at least in my mind, when I do monos or grows, it usually triggers a bunch more.
Yeah, it immediately
reducers.
yes, immediately triggers a bunch more stuff. Yep.
But then you don't look at stuff again for mono and grow. That's
No. The things that they triggered on, the triggering for mono is explicitly done by somebody who recognizes that they can trigger a mono elsewhere. And I have so few monos that I just said they're a one-off special case. Mono happens in the following 3 or 4 things. Okay. So those 3 or 4 things are all gated by these other nodes becoming a certain kind of thing. And so they all know that they can trigger a mono. So they all pump a mono as needed. And I'll probably pick them up one at a time and do the Bobby Eckhart hack and say, the mono failed because it masked a pattern and it depends on this other dude. And I'll get rid of even the special mono grow hacks. And I'll just do this one step removed from technique. The pattern denotes who he failed on and throws a dependence on that. I think that's the correct way to think about this problem.
It's funny because I have quite a few mono rules, but maybe the way I classified them is different. Like I have things like multiply becoming like multiply by a power of 2 becoming a shift. That's a mono rule.
Yeah, I might put that one in a reduce, but you could call it a mono. It's fine. It monotonically removes multiplies.
Yeah.
So, however you want to call that, but you're correct. I would do maybe you're right. We should be in mono. It's fine. So anyhow, I'm not to that point yet. I am literally I'm not doing, so that's like code generation issues with addressing modes. I'm not there. C2 has a bunch of monos. I don't have it broken up in C2 like monos like this, but it has a bunch of mono rules because it does addressing math on arrays. And I will get there and then I'll have exactly that rule, but I'm not there yet. And so I have rules that are emblematic of what I might have lots of other rules in the future of, just to make sure I can handle a variant of a rule like this. But I don't have the complete set that you'd expect. So, right now, things that are exciting in the reduce cause are like load store elimination around identical aliasing and dead code around if tests. Because I'm discovering my call graph lazily, the chat is lit up and I haven't looked at it. Dinner time, got to go, Chris. Oh, see you, Chris. When I start, I don't know who calls who, so I assume that all calls might target all functions. As I discover who the callies are, I wire them up directly into the graph, and then I reach a point where I know that a call has wired all possible targets. The target count might reduce as I run the combo algorithm, but will never grow again. And I change the call from being a pessimistic, I don't know what the hell I'm calling, to being, look at the set of things I can call and take the meat across them target things, and that's what I produce. And that's all done in like mono and reduce rules. So it's not like I'm multiplying to a shift. It's like I'm discovering the call graph at all and building it as I go. And I think most folks would start with a call graph, or they weren't doing any intercall analysis. But if I'm being a functional language, I need to do intercall analysis. So yeah, I gotta have that.
Yeah. Half my stuff is, at least half of all of my rules are about unzipping that state chain.
Yeah.
That was
for the record, intercal is one of the best languages.
Intercals?
Intercal. Isn't that what you're talking about?
No.
I'm joking.
Pretty certain I heard cow as COW, but it's all good.
No, CAL, intercal. If look it up sometime when you.
Is it written by 2 cows?
No, it is a joke language making fun of COBOL, I think.
Of COBOL. A COBOL doesn't need fun made of it. It makes fun of itself. What?
Why not? No.
No, it doesn't, because it's historical, and therefore it's a nice legacy artifact. See how far we've come?
Matt, find us a good link. Oh, there. He's so predictably good.
Find a link for intercal. Okay.
It's in the chat.
What else? Does that answer? You had a question. Oh, there's the link in the chat. Oh, I'll throw it in the doc. I'll throw it in the doc. The race is on. Somebody will throw it in the doc.
I think my question is answered. I mean, what I basically want to figure out is, this is a bit looking forward, where and how to figure out how to do function specialization, so that I can.
Oh.
I did one improvement speculatively to help me with that, which is I have like when I build the graph, I have a call site form, and then it's very simple. And then I do this pass, which is before I go into the ideal graph, because unlike you, I basically have my whole graph parsed and built, and then I start doing the ideal thing, which is less efficient, but I don't know, easier to think about. And so then once I've got the graph built, then I do this thing called build call sites, and then that changes the call site form into this more complex thing where I can optimize right through. And that's where all the complexity in terms of unzipping state chains happens and stuff. But I've got that sorted out, at least for the test cases that I've looked at so far, and I'm a little bit scared to add any, but I guess I'll have to.
Yeah, if you're scared to add, you need to add.
Yeah. Yeah, well, so I will. And then hopefully that'll be okay. And so, but then I can tear down those call sites and I go back to the previous form.
Oh,
so,
okay.
So then I can go back and forth. So the idea is that I build, optimize, figure out what's, some functions are just going to go away. They're only used once. Some will be simplified in some way, but I should be able to understand what types go into those functions and which call paths different. Maybe I can do some analysis to figure out which call path, like which specializations pay.
Yeah.
And then I can tear down the call sites and then basically create clones of each of the resulting functions that become the specializations and tie them in to specific places, so that I mean, the simplest thing is just to make one clone for every call site, and I don't need to do, and then everything would get inlined.
You'll get code bloat.
But I'd get code bloat. Yeah. So I'm doing all this because I assume that is not a valid solution.
So I have two things about specialization here. One is I'm going to hard guarantee that all primitive adds and float adds inline. However, I have to do to make that happen, and that will be done. The typer will guarantee that he knows that he can do that, and he will probably actually do it as well. But I'll guarantee that's done. Now I get into an optimization strategy, and this looks a whole lot like what happens with C2. When do you inline and when do you not? And when you inline, you effectively specialize on the spot. And that's not fair. Okay, so that's the C2 strategy. He doesn't have specialization per se. He just inlines you, and that's your specialized.
Yeah.
So there is a third zone which says this function can be called with ints and can be called with strings. And also, I don't want to inline it everywhere. I want to keep it separate. So that would make sense if the function was moderately large and was being inlined in a moderately large count of places. And then you get a lot of code bloat for not much performance gain. So you might instead specialize. And that'll be one where I haven't done that, but that's sort of a classic understood problem in compiler optimization. Yeah, you go count callers and callees and look at the bulk set of types on each of the function calls and the call sites and decide there's a common pattern, and for the common pattern, and there's a gain to be specializing. Basically, a bunch of V calls become static calls and further inline.
Yeah, yeah. Because I'm kind of thinking that I won't actually have inlining, I'll only have specialization. But the specialization means that anytime I've got a function that's only used in one way will be inlined anyway.
Yeah. So hang on with that thought for a second here. the effort is roughly the same. There's a lot of effort for making a copy of a function. There's a little bit of effort to stitch it into a call site, and that's your inlining, versus wrapping it in a header, which says it's a standalone function to be called separately with a different type of the arguments, and I have to do some call site resolution as to who calls which.
Yeah.
Bunch of effort for me, at least, was in correctly cloning a call site. Now, I have other constraints that you probably don't have. Not a call site, cloning a function body. So, you know, the fun node inline call has a split call or whatever, has a function that basically does the work. It starts out looking like, you know, hey, just copy the graph and then repaint all the nodes and all the edges. And oh, some of the edges need to stick from before and after the call so that I don't repaint them all. And all my aliases have to be doubled because I need to split them around here. And if I'm self-recursive, I need to patch call sites up and suddenly you get a lot of shit and it's complicated. And so by the time you can have a function which just says, give me a new wad of code, which is semantically equivalent to the old wad of code, you've done the 90% of the work. Now you can choose, I'm going to use the same function to do the inline, or I'm going to use it for type specialization. And I actually had that in place, and I yanked my type specializing code while I got through the whole Henry Milner hack, but I'll put it right back. So it's the same wad of code, and it's most of the effort is make that semantic equivalent new wad with all memory edges patched up correctly, and all aliases patched up, and all call sites patched up, and all that kind of stuff.
Yeah. Do your memory edges on that are inside of a function, they're coming in as function arguments, right? And that's how I did it.
Yeah, there's a fee for the memory at the head of a function, or a parameter, which is a fee at
Yeah.
the head of a function. Yeah. For memory. Yeah.
And then they also come out as projections on the return.
Yes.
Yeah, so it's the same.
That's the same thing. And then every call inside this function that you're cloning has its own patching that has to be carefully done. And then I have aliasing things like right now in my abstract machine model, I'm always full closure enabled. So I make a heap allocated stack frame. Well, I'm not going to make a heap allocated stack frame as one of my hard guarantees for performance in the general case. If you do upwards exposed fun args, you're going to get heap allocated stack frame and you shot yourself in the foot and you should know better. You know, that'll be one of the fast versus easy coding style rules or something. It'll be one of the, you know, did you really mean to make a full true closure here and capture your external state? Okay, well, if you did, then you did. And okay, but semantically, I start that way and then I yank them and they get yanked a lot, nearly always. And then I want to get yanked out of the parsor as part of just doing local people optimization rules. But if I don't get yanked and I get into a function and it's a self-recursive function and I clone a thing, because that's basically unrolling of a self-recursive function, then I end up with multiple stack frames which alias on each other. So I'm going to fix that by giving you a new alias number, and then I have to do all this fix up shit. So the clone has new alias numbers for all allocations. And in fact, the rule and the goal of the aliasing was that every individual allocation site in the entire program has its own unique alias number. And so I get that hard guarantee of not aliasing if you came from two different allocation sites. And I'm tracking that as just a cheap ass bit vector floating around.
Yeah, I haven't actually done the Lambda part yet. So that's another thing on the to-do list. So I don't have to worry about that yet.
Yeah.
Well, I've taken some, I basically made a bunch of rules to try and make things simpler for myself, including, not really allowing global variables to be declared, except at the top level of the program.
Yeah, just one layer. Yeah, sure. Yeah.
So, yeah.
I'm as I said, I'm doing a research compiler basically.
Yeah.
Allow you to write pure closures if you want to, and give you C performance if you don't.
Yeah.
And make it easy to write one or the other, and also easy to tell that you got what you wanted or you didn't accidentally get what you didn't want. No accidental bar args, no accidental.
I had an AA question actually. While you were, I saw somewhere a while ago that you mentioned that in AA you do strings are just like character arrays.
totally a loosey-goosey design plan. I haven't
Okay.
thrown tons of thought in.
Yeah.
My current theory is there'll be a basic string type, which will be, UTF-8. That will be a car array. And as an array, like an int, it'll have a class which will support string-like functions in addition to car array-like functions. So it's a subclass of car array. You have a car array and you have a string, which is a subclass of car array, and just add some more functions to the.
So will you have the like sort of string array confusion that I remember vaguely seeing in Erlang, where like if you have a string of, or if you have like an array of numbers that happen to be character range, it just renders it as a string for you. It starts thinking it's a string.
It'll be strongly typed. So if you have an array of uint8s, network bytes, it will not be a string.
Yeah. Yeah, that was just one of those odd things that I found really off-putting when I looked at Erlang, and then.
Yeah, it's a funny one, but yeah, okay. Someone had to look at it and decide that it was full of
On this
bytes and
topic,
string range.
on this topic, chars versus graphemes.
So the first easy string type is UTF-8. Then there'll probably be a U string, a Unicode string, and they'll have code points. And I don't care. I mean, I don't know what a fucking grapheme is, other than it's a code point with a, UTF not 8.
No, grapheme is like the letter A is a grapheme, but so is the smiley face with a certain shade of skin, wearing a doctor's hat and walking backwards on Mars. Right. So it's actually 6 code points glued together.
Well, you just said code points.
Yes, I did.
Okay.
Code points can be encoded. Code points can be encoded in UTF-8. UTF-8 is a code point stream.
I'm
It's
sorry.
just
I'm
using
going to
a
have
compressed
an
encoding.
array of unsigned bytes for a basic
I knew what
ASCII
you-
string.
I knew what you meant, so I was just clarifying.
Okay. And then you'll ask for if I want more encoding rules. So like the basic, give me the character at offset 17 for a standard string, will add 17. It'll be a constant time operation.
Right. But if you look at the chat, Chris Engelbert said, dinner time, gotta drop smiley face. How many characters is that smiley face?
I assume a lot. Not how many bytes?
It could be. No, not
don't
bytes.
take characters.
How many
That's too
code
ambiguous.
points?
Take bytes.
How many code points?
I don't know. How many code points? How many bytes?
It could be 1, it could be 5.
Yeah, okay. Code points.
Code
And each
points.
code point could be 1 to 5 bytes.
That's correct. Actually, I think up to 6 or 7, but
So that's 1 to 30 characters. I don't know. I don't care. That's how you read or interpret the data. There's going to be a version of a string-like thing. The interpretation is bytes-like with hard performance guarantees. And there'll be an interpretation which is code point / car like, for which indexing the nth element is expensive, but you can iterate over it fine. And you might care about it this way or that way. So if somebody has a name with an umlaut or whatever in it, and they want to inject or manipulate strings with characters this way, that should work fine on the, I would call it U string for a UTF enabled string, versus a raw ASCII string, which would, handle everything that I ever saw up until the year 2000.
Right, but the point is the concept of a string could be transparent to the developer in terms of ASCII versus UTF-8 versus code points.
I'm not there yet.
I'm not saying you want to, I'm saying it could be.
I'm right. So I'm saying my choice is, because it's a data format and it's a data format interpretation problem, that I can't tell how you intend to interpret it unless you start doing UTF-8 things directly or UTF code point things on it. So my assumption will be it's going to be a non-UTF enabled operation, because that's your intent unless you say it.
Right. So the question I'm asking, and Simon probably has an opinion on this because it's one of those that screws developers all the time.
Absolutely.
Thank you. Is it a string of code points, or is it a string of graphemes? I'm sorry, is it an array?
I'm
Is it an
making
array
sure
of
I
code
know
points?
that I have a string of bytes and something else.
Everything is bytes, so we're done there.
No,
Like,
no.
UTF-8 is
And when you
bytes,
ask for the nth character, you get plus n as a hard performance guarantee. Then there is an interpretation as code points versus graphemes, and I have no opinion on that. And you're telling me I should have an opinion, and I don't.
Yeah, I'll put 2 links into the doc just to, if I can figure out how to do that. I would encourage you to read. So it's something that I regret not doing, the grapheme support.
Okay.
And it's one of the few things that I regret. And it's mainly because how many times does a developer want the 17th character to be skin darker than, shade 3, right? That's, from their point of view, that's not a char. The char is a smiley face. It just happens to have a certain color skin or a certain hat on or whatever. And those are all modifiers. Male versus female in some cases is modifier, left versus right or whatever. And each modifier is a Unicode code point. So if you look, and I'm sure Matt can beat me to a link that shows you this, but there's like a list of emoji, and a lot of them are now like 6 code point combinations. And so you have to normalize, otherwise you can't say equals equals, right, at a binary level. And there's all these annoying issues.
Which is
I don't know.
why
Anyone else?
not the default for me.
Can these code points come in
Did you?
different order as well, or they're canonical?
Yes, that's the reason they
Yeah.
have to be canonicalized or normalized. Exactly.
Did you send the links somewhere?
I'm working on it. I'm
All right.
You can't type
one-handed,
'cause you got no
so-
fingers.
I actually
So
have
It's skiing, break a leg. Oh no, you're a programmer. Don't break your fingers. Shit, dude.
that was not from skiing. I'll have you know.
Okay.
It's a dodgeball accident. Looks like it.
Yes, yes.
Dodgeball.
I was playing with a nephew, a little kid, and he's too rough.
Yeah. Yeah.
Gotta love him.
So in
I
my
think
copious spare time, I'll promise I'll look at this. And the decision what to do about it has not yet been made. There's a decision that says I have a pile of bytes that you're going to treat as ASCII characters or 8-bit ASCII characters. That decision is made. If you're not treating it as 8-bit ASCII byte characters, then that decision has not been made. And I'll definitely leave room for either or, because that's not hard to do at this point. I've already come to the conclusion that I'm going to have subtypes on arrays and subtypes on integers, and pretty much got the infrastructure in place for that.
Yeah, we did those by mixin instead of subtyping.
Yeah,
but
okay. And, we could argue mixins versus subtypes at some point, but that's not the point. Is there's an extension mechanism. As soon as I extend an array of network bytes, I can treat the extension as
So
strings.
I'll give an example why we
Unicode.
like the mix-in approach, because if I have a byte array, I want to know that it has the byte array methods. Like I want toString to actually show me a hex dump instead of, whatever. Like so, with the mix-in, you can make it so the mix-in automatically attaches because the T is byte.
That did not make any sense.
All right, let me share my screen.
Well, then you have to wait till I
Sure.
do the thing. All right, try now.
Okay. So
Increase your font size.
you bet.
Yeah, great.
I'm used to having to switch it all the time because we do code reviews on a movie screen. So, so actually, what do you know? I have it highlighted. So this is the array type, and sorry, this is the array class, and this is the mix-in that it applies automatically when the element is a byte. So it says automatically incorporate the byte array mix-in, but only if the element type is a byte.
So it's like a specialization for a type, for the element type.
It's like an auto composition that occurs at instantiation time. So when you instantiate an array of byte, it will automatically pull in this mixin, which, you know, if you look at ByteArray, what does it have? Well, for example, you can ask it for a given offset to give you a character and how long it is. This is handy for when you're parsing in the middle of a ByteArray. You can, yeah, we do packed
read bytes in a row for ints. For a network, you're going to do reverse byte flip-floppies.
So we can convert a ByteArray to an int 8 array. So signed int 8. We can convert it to a signed or unsigned int 16 array. So this is kind of what Java does with the direct byte buffers. With the byte buffers.
You're asserting the size is aligned properly.
I am.
Is there any other guarantee the size is aligned properly? You're just got a runtime error.
That's a runtime error. Yeah.
Okay, it's an unavoidable runtime error. You've said assert, but it's actually an unavoidable crash and burn if you failed it.
Yes.
You can't turn off asserts.
Well, if I wanted it to only run in test mode, I could say assert test. Okay. That's the Java assert. We've used it like twice. Almost all the time when you're asserting, you actually want it to run.
I have asserts that are too expensive to keep on all the time.
Yes, so we also have that's a 1% assert.
Yeah, okay.
So 1% of the time, do this check.
Yes, okay.
I don't care how it's done, just
I need it deterministic across all threads so that I can repeat in the debugger and get caught the same assert at the same time.
So the reason I added that is because there are a bunch of things that I've built in the past where I needed a test to occur every so often to catch some bug.
Yeah.
But if I put it in every loop,
it was too much.
It would take 4 days to reproduce.
Yeah, that's a good answer. I have the assert that I turn on or off if I see the kind of failure that involves it, and then I go to slow mode. Whereas a 1% would be a useful way to run all the time. I still want it all the time when I'm trying to track it down, but if I want to catch it in the first place, the 1% answer probably works. So
and then these are the actual conversions. So the as ones don't actually, these are not persistent methods. These actually leave the underlying, they produce a new view on top of the underlying bytes.
Yeah.
The two methods actually, they reify, meaning force the copy.
Yeah, okay.
So that way, so you can say, for example, I have an array of byte. I can say, well, give it to me as an array of int 16s that are, I want a mutable array. By default, it creates a constant one. But you know, the main thing is this stuff like this, like hex dump, right? Like every language I've ever worked in, ask Mark Falco, I write at least one hex dump.
Yeah, that's not a bad answer.
Because, and now hex dump, it's not on array, it's on any array that happens to be an array of byte. So anyway, feel free to steal ideas.
Yeah, maybe I'm hearing the view notion, which I have not explored or thought about over an array, is a useful concept.
It is, and you actually see, and I'm sure Matt will point something out with iterators in C++, you see like there are at least 10,000 pages of arguing I've read on the C++ arguing list, whatever they call it, about, you know, copy versus reference and so on and so forth. So that's just the way we formalize it, that, you know, if it's not, some things are guaranteed, other things aren't. And the as one, if you make a change to say the int array, it'll actually change the underlying byte array. But then if you reify it, what you're saying is, no, I want you to sever that connection. So at that point, you get an array that doesn't change the underlying one.
I think as the view as a conversion on demand, it still keeps the underlying collection, but it converts an element when you ask for it.
Right. Yeah. And as we know in assembly, there is no actual conversion because there's no actual type, right?
But you had to do an indirection on the guy who's asking the question has got an indirection cost, because he did some sort of vtable lookup to get a byte, which just said treat what you got back as a 16 or an 8 or whatever it's going to be.
Yeah, but once you specialize it to Derek's point of view, there's no vtable involved.
Yeah, okay, fine. Yeah,
And
yeah.
and you can look at the same array of bytes in memory. You can look at the same memory region as an array of bytes, as an array of signed int 8, as an array of unsigned int 16, and so on.
That makes good sense. Okay.
So
Yeah, that's worth thinking about. I was going to have variations on interpretation with subtyping, but you're suggesting a view, or what you call mix-in. I'll have to think about that one. And then guaranteed specialize the use points. Those are the same as my guaranteed inline primitives.
right, not at all a dissimilar concept, just a different mechanism.
Yeah, yeah. All right. Are we slowing down? It's 11:40.
Somebody has a new topic, maybe?
Yeah.
Simon hasn't told us anything today.
Alan has
No,
wants
it's
to say
fine.
something.
No, I was thinking, but then I realized I didn't have anything to say. I was too busy the last 2 weeks.
All
With all
good.
this-
Simon, does you have something new to show us in core?
Actually, not really. No, I had an insight that maybe regarding my problems with all the unified condition things, maybe I should really give it a try, not going from the direction of the if then else and trying to extend that with pattern matching, but going from the direction of the existing match keyword and making it support the things it currently doesn't do. And yeah, I mean, at the moment I'm a bit busy.
Okay. Well,
Actually, there's a question that just about H2O. I don't think it's a big topic, but I was kind of curious, like what do you describe the use case of H2O as? Like what case, like what's some good cases where you would use that? Because I was looking at the website a little bit and I couldn't really make much sense of it. I didn't look that hard.
Snowflake.
I disagreed with what the CEO is doing, but we parted ways a long time ago. So as
It's
far as I'm
basically
concerned, H2O is a really nice big data calculator. So machine learning calculations, data prep, data cleaning. It's fast enough to do really decent exploration of large data sets, where large is in the range from modest kilobytes to modest terabytes. If you're less than modest kilobytes, you're probably ought to be using Python or R. If you're above multiple terabytes, I probably need to do some more engineering work to make it reliably run that well. The largest common data sets we saw in the fintech startup were about a terabyte on disk. They would compress to 256 gigs, which would fit on a reasonable expensive server. Like these guys, that kind of server was no big deal. It was part of the cost of buying the product. They just bought one big ass memory server. So we never went clustered, but it totally supports clustering for higher terabytes or smaller. You know, you go to Amazon and get 8 gig micro units for next to nothing and stitch 100 of them together. So now it's math time, and it's really reliably achieves memory bandwidth of compressed data per pass kinds of speeds. At those speeds, you can do grep-like searches faster than you can type them over terabyte-sized data sets by doing brute force. Hey, go do a fancy indexing with binary search and all kinds of cross. No, fucking drop all that complicated shit. I just brute forced everything, but the brute force is brutal. It is so fast.
So you know where Mark Falco works now, right?
No, I don't.
Speaking of brute force and loops,
Where do you work?
Come on,
You work at
Snowflake.
Oh, so there you go. but you're doing database things. Yeah, okay. So I worked for a competitor, a wannabe competitor. They were using the wrong language under the hood. I could make H2O do the SQL TCP/H queries on my desktop here that were entirely point for point competitive on speed with somebody's top of the line fucking expensive hardware for doing TCP/H query cell products, right? I could sit down and the loops were obvious and easy. Once I figured out how to do the fucking query in the first place, I knew the query plan told me, oh, that's how that works. Okay. Once I did that, the actual loops I wrote in H2O were obvious and simple. For I equals to bazillion, throw things in hash tables or not, or whatever it was going to be. And I got numbers which were, totally competitive with state-of-the-art hardware and state-of-the-art systems. So it's a fast way to do big data crunching.
Are there any YouTube videos or presentations out there that are good for actually seeing how to make use of this? Because it sounds good.
Right.
But it looks like looks like a big tool. Like it's a big repo, and I don't know. I don't when I have these types of problems, I don't have like the time necessarily to try and figure out.
Okay.
How
so let me tell you the disagreement between me and the CEO. I built a tool. He wanted to build a product that he could charge for, and the disconnect was that the guys who would use the tool needed to have a tool like Pandas and NumPy, Python, PyTorch, right? The Google version of things.
Jupyter Notebook.
And what he was wanting to do had shiny covers and clicky button pressing, which does not make for a good data exploration tool per se. It hit a different market and not necessarily a bigger one. Fine. When I take H2O and go do it as a product myself, I strip all that shit out. I get a Java jar file. And I start with a main, which does hello world. And then I say, and now go find this data set. And then it gets into like, now I'm writing data set manipulations in Java to do my data set exploration. If I grab H2O, the tool, and I use it as the clicky thing, if you follow the tutorial on inload install, it does what it does and does it pretty well. If you want to step outside that, you're now sort of in the more world of hurt, right? So I don't even bother. It's not fair. For doing new customer work projects, if I were to start again, I would grab the base tool and immediately explore their data set for the basic shit that goes on, right?
Yeah.
The fintech guys had a bunch of data sets. I needed a little this, a little that. Oh, now they have this. Oh, now I can see these properties, and H2O will pop them right out like in a heartbeat. Okay. Then I want to start doing some machine learning for real on it. Drop the GUI interface, drop all that other shit. I'd go straight to Java.
Yeah.
And I have given plenty of YouTube videos on how to use it as a Java tool. I can drag them up. You can find them if you look.
Okay. Well, I can search them out.
H2O should have been an engine and a product with a product on top.
Well, the front GUI interface always had its issues about not being programmable, and people doing big data math kind of want a programmable interface because they're usually splitting their time between data exploration or the product guys who don't need the clicky interface. They need a script that's just going to pound it through. So, the clicky thing was for sales, but as soon as you went beyond sales, you needed a nice tooling interface. And the H2O tooling interface to Python and R got a fair bit along, but not reached the point where I saw a bunch of people in the audience using it as an interface to an R. Like, we totally have a way we could take a Python on your laptop, back it up to H2O in a cluster. You can write Python code that does Python codey things. And wherever you talk about this data frame, like a Pandas or NumPy data frame, you talk about the H2O equivalent, which is almost identical. It would do H2O things in the cluster, which gives you some interesting kinds of exploration on your laptop for a terabyte size data set. Okay. And then the failure mode is that you can't do everything Python does and will auto parallelize it because it's going to get turned into Java bytecodes in the end and run on the Java cloud. So that didn't work up to, bulk data, Python operators worked. Anything that you did the inner loop, which is complicated, had to be broken up to bulk data steps or it didn't fly. And so, it only went so far. Fine. So like I said, once I hit past the point
you needed to use Jython.
Well, we did, but that also has its issues. The big data fintech guys, the data science team was Python. We used their data science models in Jython. We did, but we did a butt ton of work to make that run well. So I'm not ready to run Jython on the hot inner loop of an H2O just straight up because you just die a GC death. Too crazy, inefficient. The work I did for the fintech startup was to break up my data sets and the Jython in such a way that we wouldn't die the GC death and we would get good parallelism and all that kind of shit out of it. Fine. So yeah, to your point, once you're past what they show on their webpage, I would be prepared to switch programming languages and be prepared to drop all the wrapping tools and go to the core Java thing, which itself is not that bad.
Yeah.
There's a fairly straightforward way to open a file and parse it in parallel, inhale it, and then do things on it in bulk by writing simple Java loops.
Yeah.
And
so
you'll get that performance. You'll get that memory
Yeah.
bandwidth performance.
So a few days ago, I posted this link to this tool that I played with a while ago called the TechML dataset. I don't know if you ever clicked that link, but it seems like it tries to do something similar because there was this short conversation about if languages could, do, joins on arrays of maps and stuff like that, and I pointed out, well, actually, there's this library, this TechML dataset that kind of does that. And they try to be, performance focused and cache, think about how data is arranged in the cache and whatnot. And it's about sort of getting tables of data and querying them and joining them and doing stuff like that. And is that sort of what you're doing with what you can do with H2O as well? I can post this link again here.
Yeah, I mean,
I
it
think
sounds like it.
Is the fifth link?
You get a 2D table like effect. You can add and subtract columns sort of freely for no cost. You can do joins and do the usual, filtering operations. The common mode is that you do a bunch of cleanup and joins in the beginning to get the data set you like. Once all that's done, you then apply some of the baked-in ML algorithms, which are actually completely the top-tier, robust ML algorithms with all bells and whistles.
Yeah, okay, that's something I think that dataset library does not have. I don't think there are any.
Okay, yeah, no, we've spent a lot of energy to get the best of the best for the algos. The cleaning steps are easiest done in Java, in my opinion. That you can have R and Python hooks for them, but it's not hard to write.
Yeah.
And then joins and shit like that, that all just works like fast and well.
Yeah.
So
yeah, okay.
Your data set's large enough, you're having trouble finding an easy way to manipulate it. Like you're past what you can do well in Python. I think H2O is a good job.
Yeah. Yeah, I think I need to take some time and figure out how to make use of it. It seems like a good tool to have at hand when you need it. Anyway, that was my question. But if you have like I just did a search while you're talking of videos that you did. Yeah, and I realized you've got lots of videos that you've done.
Yeah.
On this. If there are any that you could throw in that's a good place to start, that'd be.
Well, so there's using it as for real, and then there's theoretical how it works. The using it for real, I don't have a good video on because my first step is to chop the giant Gradle file, throw away the Gradle file, throw out all the other directories except the Java directories, make sure the make file for Java does the right thing, and then find the hook for main that, main has to start H2O somebody has to be outside, somebody has to be inside in terms of, you know, like who's the controller, and I usually let H2O control, but if I'm doing some other kind of application, I'll have somebody else be the controller and they have to launch H2O. You can get H2O started
Right.
and you call what you want to do in a main, and now you have a blank Java slate with H2O around you, and then you start doing things like H2O dot parse file quote string quote. And
So you can't really start using it by just grabbing a jar through Maven or something. You've got to like sort of build.
I don't know if you could get a pre-cooked jar from Maven. That's a good question. I mean, you know, it builds fast enough in just the Java piece, and you only build it the once. If you separate out your main from the H2O main, you don't have to build it again.
Yeah.
I usually leave it lying around in case I want to add some functionality, but I know how to add functionality to it. I didn't have to add very much for the fintech. Mostly I took what they had, except the parser got a little magical, but I did that as a post parsing phase. So yeah, I don't know that I added anything to the core H2O. So I might have been able to grab a jar file. I didn't try that. That would have been 10 years ago now, something like that. So maybe now wasn't possible then, and now it is.
Yeah. Okay. Well, I have to look at it a bit. Okay. Well, that was sort of my random H2O question. Thank you.
Yeah.
Just writing some code.
Yeah, I'm showing a progress on something that interestingly works now. So
Maybe share a screen for last time.
oh, I can do share screen. It's very simple, and I should stop and we should go eat lunch and dinner or whatever. But I do just this thing and be done. Not a thunk, but what do you call a no closure function? A lambda or a function? What do people want to call that? You know, Java function here.
It's like a lambda that's not closing over anything. Just a function.
So I have a string, which is a function here. The function is 0, return a pair of z applied to 0, z applied to some string. What's that type? There's a flow type, which says this happens to be function 54 because I have 53 primitives. So it's the next one up. And it doesn't take a closure. So it's a bare, has no upwards exposed fun args. Doesn't have any state it needs from outside.
Yeah, parameters only.
Parameters only, yeah. The 4 is the first 2 parameters don't count. The third is the display, which is going to be not needed here. And the fourth is Z. So, you know, however you want to ignore the 4. Returns me a pointer to an alias 12, which is a pair of scalars. Means I don't know what it is going to return, but it's a pair of them. That's the limit of what you get out of the flow type. The Hindley-Milner type says I have a function which takes an A, that's the display, which is unused. So there's no upwards exposed fun arc. So my displays are explicit in Hindley-Milner. That in turn takes as the next argument, the Z is typed as another function with a display which is ignored, and either a nillable ABC. I know it only ever passed nil or ABC, and no other values are passed into it. And whatever that function does, it returns a C. And then the overall function returns a pair of C's, a pointer to a tuple of C's. So that's the current typing I get out of this guy. And that was one of my Hindley-Milner types that I would never ever do on the flow typing, which looks a lot more like random junky C code. So just, you know, progress of some kinds. Yeah, and you could tell me that you want to call a function a lambda. If it has no upwards exposed, it's just parameters only. There's no external state. needed here, then
You know, what Bobby posted was that it's sometimes called combinator.
yeah, but I want to use a name that is more meaningful to like average, like I see,
Average
Bobby.
PhD.
Yeah, okay. Right. Yeah, fine. That's all. I mean, I have more of these things now.
I like the
but-
word. I liked the word combinator until I came across the Stephen Wolfram's 3-hour ramble on combinators, which was something completely different. And I was like, I think I'm just going to avoid that term from now on.
Well, you know, I've heard things like, what do you call the kind of a function you get out of a C compiler when you just put an anonymous function in it? Java anonymous function. They're called a lambda or something. They have a clear constraint. They don't do closures, right? So what do you call them? What do they get called? Lambda. I can use a lambda here. Fine.
Yeah.
Yeah, I mean,
If it's
definitely in some contexts, people call lambdas.
if it did not capture anything, a lambda, a function with 0 arguments, a thunk.
Yeah, no arguments, thunk, which I totally am used to. The distinction between I captured my upwards closure or I didn't.
If you
not-
capture a closure,
Yeah, if I did, I'm calling it a closure. If I did not, now what do I call it? I don't care.
Just a
Lambda
function.
and closure is often pretty synonymous.
Yeah, right. And so function might be better than lambda. I don't know.
just a function, just a
This
function.
is all jargon.
Yeah, why not?
Anyhow,
it's
all that
function.
happened there was I recognized that the return from Z came out twice. Therefore, I have a pair of whatever Z returns. And that Z was a function and it's only ever passed 0 and ABC. So that's all it needs to handle on its inputs, which probably gets generalized to string or nil. But I know for a fact that this is your constant. So if somebody's saying, yeah, you recognize constants. Yeah, string ABC is a constant string. Okay. Done. I have several such things of more interesting flavors. I'm doing the untyped operator plus guys right now, and they're actually coming along fine. I think I'll be done with them today or tomorrow, like pretty easily, I think. And then I have things like that X plus Y example where X is known to be a 1 or Y is known to be a 1, changes the signature a little bit, but not much. I still end up with the same problem. I don't know what I've resolved.
My comment on this is that it should actually require more information to actually know what the plus means. Like in
Yeah, it does. That's the issue right
X-
now is I report an error there.
you have
Because I
to
have not resolved what the plus means.
you have to include more information from the user, be it like a type classes, to be a num, be it like an interface to extend something that
Well,
extends.
that's what the
num.
type is. So let's scroll up here.
Hmm.
The type is exactly here. I demand that the X argument has a class with a plus in it, but I don't demand anything else about it.
But you still don't know nothing about X and Y. But for a Java, this
No,
is an
I
object.
know X has a class with a plus,
Hmm.
but nothing else. But I know it has a class with a plus. And that's all I can get out of that.
Hmm. It has to have
And
the
right now I
plus.
report an error for that and I want to let it slide and say it's not yet resolved. So every concrete call site has to be resolvable. That's not yet resolved, but also the only time you would get it is if I export it outside. Like if the program consists solely of I'm exporting the function, well, the entire program is return a function pointer, which is some number to some address space in memory, but no one ever calls it. Because that's the entire program.
At
Okay, if I make a
first,
module, which I'm going to link against, then the module gave me a function that I do need to eventually resolve the operator plus, but I don't need to resolve it at the time I make the module with the operator plus. I need to resolve it at each concrete use site.
yeah, that will be my comment. At first sight, not requiring more type information here in the declaration maybe seems fine, but you have to work with the X and Y inside the function. You have to know more about an
right.
X and Y here.
So let me
Be useful, in order to be able to compute.
Yes.
anything.
So let me be clear. The first two lines taken together, if that's the complete program, add does not escape to the outside world. Add is used in two contexts, one with ints, one with strings. Both of those type fine. Here I am fine. I resolve the operator plus once differently for each time on the inside. That's okay. Code emission time, I need to go specialize. Typing time, I got this one.
Mhm.
If instead I export add, I'm going to claim the add I exported did not get all its pluses resolved because there's some unknown guys out there who are going to call it that I don't know yet what they are. And therefore I claim an error now, as opposed to delaying the error until the unknown guy actually takes his add and calls it with somebody who doesn't have an operator plus.
Okay, that's what I'm got. That subtly changed the behavior, but if it's used globally, you have to be able to resolve all instances of plus.
Yeah, I'm
like,
claiming I'm being too aggressive about catching it. I'm saying all uses have to be resolvable. Here I have two uses. They're all resolvable. I'm done. If I export it, I have more uses in the unknown world, the unknown exported world. Those are not resolved. Therefore, I'm claiming an error right now. And I need to not do that.
Will you claim you want to put type annotations?
Yeah,
or
basically, the exported world might make an error call here.
Of course.
And then I have an error. So I'm reporting it now instead of delaying it until they actually make an error call. And that's that bug du jour of this set of things. So it's in progress. All right, we're done here, I think.
Yeah.
This was just me like fine grains of when do you report and what do you know and what you don't. All right, any final comments, people, before I declare victory here? All right, we're done.
Yep.
Till next week.
Yep. Bye.